The motherboard is the backbone of a computer. It connects all the components together. At the heart of the motherboard lies the chipset. The chipset is a group of chips. These chips control the data flow. Data flows between the CPU, memory, storage, and peripherals. A simple analogy is to think of the chipset as a traffic controller. It directs the flow of vehicles or data on a busy intersection, which is the motherboard. Without the chipset, the components wouldn't be able to communicate effectively. This would lead to a chaotic and inefficient system. The chipset determines many aspects of the system's performance. These aspects include memory speed, storage options, and expansion capabilities. Understanding the chipset is crucial for anyone who wants to build or upgrade their computer. Choosing the right chipset can significantly impact the overall performance and functionality of the system. The chipset is essentially the brain of the motherboard, making sure everything works together smoothly. While the CPU and GPU often steal the spotlight, the chipset plays a crucial role in the overall performance of a computer system. It's the unsung hero that enables seamless communication and data transfer between various components. The chipset dictates the type and speed of the memory supported by the motherboard. It also determines the storage options available, such as the number and type of SATA or NVMe ports. Additionally, the chipset influences the expansion capabilities, such as the number and type of PCIe slots available for graphics cards, sound cards, and other peripherals. A high-performance chipset can unlock the full potential of a powerful CPU and GPU by providing a fast and efficient data pipeline. It ensures that data is transferred quickly and smoothly between components, preventing bottlenecks and maximizing overall system performance. Overlooking the importance of the chipset can lead to a system that's held back by data transfer limitations. This can result in slower boot times, sluggish application performance, and reduced gaming frame rates. Therefore, understanding the capabilities of the chipset is essential for building a well-balanced and high-performing computer. Traditionally, chipsets were divided into two main components, the Northbridge and the Southbridge. The Northbridge, also known as the memory controller hub, was responsible for handling high-speed communication between the CPU, memory, and the graphics card. It was the faster of the two chips and was directly connected to the CPU via the front-side bus. The Southbridge, or input-output controller hub, handled the slower peripherals such as hard drives, USB ports, audio, and network controllers. It connected to the Northbridge via a slower bus, allowing for a hierarchical communication structure. This two-chip architecture provided a clear division of labor, with the Northbridge handling the most critical and high-speed tasks. However, as technology evolved, the lines between the Northbridge and Southbridge began to blur. Modern chipsets have integrated many of the Northbridge's functions directly into the CPU, resulting in a faster and more efficient design. The evolution of chipsets has been driven by the constant pursuit of faster and more efficient computing. Older chipsets, such as those based on the Intel P965 or AMD 790GX, were designed for CPUs with lower core counts and slower memory speeds. They featured separate Northbridge and Southbridge chips and offered limited expansion options. As CPUs became more powerful with higher core counts and faster memory interfaces, chipsets evolved to keep pace. The introduction of PCIe as a high-speed serial interconnect replaced the older PCI and AGP slots, allowing for faster graphics cards and other peripherals. Modern chipsets, such as the Intel Z790 or AMD X670, represent a significant leap forward. They feature integrated memory controllers on the CPU die, eliminating the need for a separate Northbridge chip. This integration reduces latency and improves memory bandwidth, resulting in snappier system performance. Furthermore, modern chipsets support the latest connectivity standards including PCIe 5.0, USB 4, and Thunderbolt 4. These advancements provide significantly faster data transfer speeds for storage devices, external peripherals, and displays. The evolution of chipsets has been instrumental in unlocking the full potential of modern CPUs and enabling the development of increasingly powerful and feature-rich computing devices. Section 5. Modern Marvels Chipsets of Today. Today the chipset landscape is dominated by two major players, Intel and AMD. Both companies offer a wide range of chipsets catering to different needs and budgets. Understanding the key features and differences between these chipsets is crucial for selecting the right motherboard for your system. Intel's current lineup includes chipsets like Z790, H670, B660, and H610, each targeting a specific segment of the market. The Z790, being the highest-end offering, provides the most features and overclocking capabilities. It supports PCIe 5.0 for both graphics and storage, allowing for blazing fast data transfer speeds. AMD, on the other hand, offers chipsets like X670, B650, A620, and X570. The X670 is AMD's flagship chipset, supporting the latest technologies like PCIe 5.0, DDR5 memory, and USB 4. It caters to enthusiasts and gamers who demand the best performance. Choosing the right chipset depends on your specific requirements and budget. If you're building a high-end gaming PC and want the latest features and overclocking headroom, the Z790 or X670 would be ideal choices. However, if you're looking for a more budget-friendly option for a general-purpose PC, the H610 or A620 might be more suitable. Section 6. The Intel Landscape. Intel's chipset lineup can be a bit overwhelming with its numerous letters and numbers. However, understanding the key differences between them can help make an informed decision. The letter following the series number generally indicates the target market and feature set. The Z series is designed for enthusiasts and overclockers, offering the most PCIe lanes, support for faster memory speeds, and advanced overclocking features. The H series is aimed at mainstream users, providing a balance of features and price. They typically support overclocking on specific processors, allowing for some performance tuning. The B series is targeted at business users and casual users, offering a stable and reliable platform with essential features. Overclocking is generally not supported on these chipsets. The Q series is designed for business systems, offering features like Intel vPro for enhanced security and remote management capabilities. The F series is similar to the main series but lacks integrated graphics support. These chipsets are ideal for systems with dedicated graphics cards. By understanding these distinctions, you can choose an Intel chipset that aligns with your specific needs and budget, ensuring optimal performance and compatibility. Section 7. The AMD Arena. AMD's chipset naming scheme is relatively straightforward, with each letter typically representing a specific feature set. Like Intel, AMD offers chipsets catering to different market segments, from budget-oriented builds to high-end gaming rigs. The X series is designed for enthusiasts and gamers, offering the most PCIe lanes, support for faster memory speeds, and advanced overclocking features. They are AMD's top-of-the-line chipsets, delivering maximum performance. The B series is aimed at mainstream users, providing a balance of features and price. They typically support overclocking, allowing for some performance tuning. The A series is targeted at budget-oriented users, offering essential features at an affordable price point. Overclocking is generally not supported on these chipsets. AMD's chipset lineup provides a good balance of features and affordability, making it a popular choice among PC builders. By understanding the differences between the series, you can select the AMD chipset that best suits your requirements and budget. Section 8. Choosing wisely, the Chipset Conundrum. Selecting the right chipset is crucial for building a well-balanced and efficient computer system. Several factors come into play when making this decision, including your budget, desired performance level, and future upgrade plans. Firstly, consider your budget and the features you prioritize. If you're on a tight budget, opting for a lower-end chipset might be a wise choice. However, if you're willing to spend more for higher performance and future-proofing, a higher-end chipset would be a better investment. Secondly, determine your performance requirements. If you're a gamer or content creator who demands maximum performance, a chipset with support for faster memory speeds, multiple graphics cards, and ample PCIe lanes would be ideal. However, for general computing tasks and casual gaming, a mid-range chipset would suffice. Lastly, think about your future upgrade plans. If you plan on upgrading your CPU or graphics card down the line, choosing a chipset that supports the latest technologies and provides sufficient expansion slots would be beneficial. This ensures that your motherboard can accommodate future upgrades without needing a complete system overhaul. Section 9. The future of chipsets. The world of chipsets is constantly evolving, driven by the relentless pursuit of faster and more efficient computing. As technology advances, we can expect to see chipsets with even faster data transfer speeds, support for next-generation memory and storage technologies, and enhanced power management capabilities. One significant trend is the increasing integration of components onto the CPU die. We've already seen the memory controller migrate from the Northbridge to the CPU, and this trend is likely to continue with other components like the graphics processing unit, or GPU, and even storage controllers being integrated into the CPU package. This integration will further reduce latency, improve performance, and enhance energy efficiency. Additionally, we can expect to see chipsets with support for even faster PCIe versions, potentially reaching PCIe 6.0 and beyond, enabling lightning-fast data transfer speeds for graphics cards, NVMe drives, and other peripherals. The future of chipsets is exciting, with continuous advancements pushing the boundaries of what's possible in computing. By staying informed about these developments, you can make informed decisions when building or upgrading your PC, ensuring that you're equipped with the latest and most powerful technology.